My name is Michele Pasca di Magliano. I'm a senior associate at Zaha Hadid Architects in London. And obviously it's great to see that there is so much attention about 3D printing and there is so much media attention on 3D printing. What I'm really interested in is how it affects the market I'm in, how it affects the construction market, and how we can actually use 3D printing to inform architecture and move that forward. So it's really, the presentation today is about how, in my 10 years at Zaha Hadid, actually 12 years at Zaha Hadid Architects in London, we've decided that we had to use 3D printing. We had to originally outsource to a lot of the companies we have outside, and then we ended up installing a full-on working workshop in the factory, in the studio in London. And we have 3 machines at the moment where we manufacture our presentation models, mock-ups, prototypes, and we also do all our design studies. And obviously, what I foresee as a kind of next step for 3D printing in the architectural industry. So we work in London. Our office is based in Clerkenwell. It's a traditional old Victorian school. But actually, we have been, since the setting up of the company, Zaha has always been interested in being at the forefront of architectural design. She entered a competition in Hong Kong 30 years ago now, where she was not invited, and yet she won the competition. And one of the reasons why she won the competition is that she was always challenging the status quo. We were always trying to come up with new spatial configurations, new geometries. And with that, obviously, come the needs to study new ways of representing architecture and new ways to build it, obviously. So most of the early work was done with painting techniques and let's say, traditional model making and deforming paper models or wooden or even foam models. We get to a point where actually our architecture started to be more complex, more and more because of the needs of our clients, because of the reality in which we were inserting our buildings. This is one of the early sketches for our Maxi Museum in Rome, where we actually were trying to use modern architecture not so much to kind of create an icon and place an alien object on its site, in a site in Rome, but actually to think about how we can use the advantages of complex geometry to really intertwine a building in an historic environment, such as the city of Rome. And obviously, when it came to model building and to kind of display this project, we had to resource to ways of, let's say, bending paper or pleating paper. We were very limited in a way we could actually represent this in a built form before actually building the building, and let alone the construction process, which actually ended up to developing all new forms of formwork and creation of concrete shuttering systems to be able to actually build the images you see behind me. Some of the projects actually got to a point where the geometries were not just deformed in plan view, but in 3 dimensions, and that obviously then creates a whole new set of challenges, because you are not anymore able to work with sheet materials and bend them on one direction, but you actually have to come up with a way, as we see here at the bottom of this building in Germany, the Phnom Science Center, where we actually have a slab that becomes columns. So we don't have any more traditional architectural categories where you divide buildings in facades and in slabs and in columns. Actually, here the idea is that we have a facade that folds up into a slab and it falls down into kind of some sort of vertical structures. You may call them columns or you call them voids, but anyway, those are part of the same. They were built in concrete at the same time as the slab. So, and that's actually a picture of the finished building. We could do that with concrete, because obviously it's a liquid material and it gets cast and molded into a steel or wood shuttering in this case. But when it came to model building, we faced a lot of limitations in how actually to represent this building, how to study it. And we cannot do all our studies purely digital. We also always have to have some level of physical representation of the building. So we were limited to printing what we call paper relief models, which are, let's say, a 2D representation of a 3D perspective, or using materials like balsa, wood, materials you can carve out, where we found obviously it's a very fascinating process, and we can produce very beautiful models. At the same time, you have a huge level of approximation, because you can work by layers. You have to glue the layers back. you kind of refine the geometries, but you're never going to be able to get to the level of precision that the 3D model actually expresses. So there is always, it's very hard also to check the actual geometry of these models against the original building. So really 3D printing for us was really something that came naturally. We've always been interested in organic forms and in integrating new geometry in the built environment. That's a beautiful example of an opera house in China, in Guangzhou, where in this case, even on the construction side, we face the limitations of what could be done with the stone and what shapes and geometries we actually achieve on the stone. So for us, getting to the idea of having something that is not limited by starting with sheet material was pretty much a natural process. And we always, I mean, throughout university and since I started that practice, I mean, I'm an architect, I'm a designer. I'm not really a specialist on 3D printing, but we really saw the need of a new way of building our models. And the reason why that is that our world, our design world, is more and more digital. We work with 3D modeling softwares, which are used across a whole range of industries nowadays. But basically, most of the design process is done on a computer, on a software platform. We then have, let's say, the need for quick internal reviews, the need to quickly being able to have printed models of the building we do, that we can see them, we can check them, Zaha can approve them. And that's one of the things that really led to, first, to outsource a great number of models, and then to think about installing our own 3D printer in-house. Obviously, internal presentations is a great moment of debate. This is our main meeting room in the office in London, where we have an internal presentation on one of the staff members. The presentation is done on screen, but then you have models around the space, and you need to be able to interact with those digitally. So somehow traditional model making techniques are always seen as something we need, but also as a limitation from the design process to the build element. And we saw that there was a gap that was opening up at that point. This is one of the very first models we 3D printed for a competition entry, which obviously we didn't win, and there is a reason for that. When we did this competition entry, no one had seen a 3D printed model for architectural. All architectural models had windows and doors and glass, and they were very nice. And then we came up with this SLA model, which turned yellow after a week. And obviously, it wasn't the final product we even wanted to do. But it was the pure representation of our geometry. So actually, we are very proud of this model, even if it lost us competition, because it was the first time we actually printed the model, and we finally could print exactly what we've designed. So it was a bit of a, let's say, a turning point of our practice for the way we're representing our projects. And we thought, okay, if we really show the geometry we build, and you can see it in a physical form, not only on a computer screen, then they will really convey different messages to our clients, to our consultants, eventually to the contractors. And then there is obviously an education process. Nowadays, everyone is used to seeing 3D printed models. You can get your picture 3D printed in the street. At the time, no one had seen one, so it was very different. We had a very different reaction. This is the first competition we won with a 3D printed model. So this was a tower we designed for a Milan project, which is now under construction. And in this case, you know, we used the 3D printer we had. We managed to have a better color resolution. That was probably 9 years ago or something like that, 9 or 10 years ago. And we needed a 3D printing because the tower geometry is not a straight extrusion, but it's a twisted extrusion. So there's always the need. We wouldn't want to, let's say, design traditional architecture and then come up with innovative ways of building it. We actually see the two things going hand in hand. So we see that with this particular case, we have something that needs a particular technology, and we use it to its best. And bearing in mind, that's a fairly old model. We designed recently the Aquatic Centre in London for the London Olympics. Obviously, we're very proud of that. And that was a project that actually went across the office for a few years, in which we made extensive use of 3D printing. Not so much for the first presentation or competition model, but actually for something slightly different. We actually, as you can imagine, the whole Olympic process, the Olympic Committee was a highly political project, was a highly was a very, very long process to get the right approvals in place. There was a lot of international monitoring. So what we had to do, we actually had to do at key stages of the project, we had to present to the key stakeholders, to the client body, to the Olympic Authority, the delivery authority. We had to present how the project was developing. And of course we had plans, of course we had renderings, but what we found as the kind of the most useful way and most convincing way of getting this project across was actually creating a series of study models, which we did throughout the different stages of the project. So that this is the very, very initial stage of the project. As you can see, it's very, very different from, I mean, some of the, let's say, intuitions or formal ideas about the project are there, but it's very different from what has been built now. This is just one of the stages that I found an old picture in the office of, where we're actually doing studies of what if we were extending across the bridge to the water polo arena, and what if the wings of the pool were actually bigger. Here we had a series of options where people were telling us, you know, you have to be careful, Olympic budget is under great level of scrutiny, we really have to check the surface areas, and at the same time we said yes, but you also have to check what is the final product and what you're going to get. So actually here you can see on the top 3 images are 3 study models of possibly options that some contractors, some of the consultants thought that would have been easier or cheaper to build, and on the bottom is actually the model we ended up building of the final building itself. And again, this is really just to show you how the 3D printing process is actually come across in different stages of our design process, all the way up to the construction of buildings and potentially even afterwards. One aspect I'm particularly interested in, and where I really see a lot of potential in the built industry, in the construction industry, is actually the construction itself. We are in a stage where actually most buildings, they either get built off-site and then transported to site, or they require a huge amount of, let's say, leftover materials, call it shuttering, call it protection, call it materials to actually build the building in place. In this particular case, we have a very, very complex building which was opened last year in Seoul, in Korea. It's a World Design Center. If you see the scale of let's say the blob at the base of the image, that's obviously our building. And you see the scale of high-rise towers surrounding it, you realize how big this building is. It covers an area of 100,000 square meters and basically has taken over a whole park and a former stadium. And here, one of the complexities we faced was really how to then build this building in aluminum panels, which was the material choice for a number of reasons. How do we actually face it? How do we actually model it? So most of the work was actually done as part of the digital tooling software, but then at the same time we had to think how to build it. And in this case we did not obviously use 3D printing because it was not, let's say, a suitable system to use, but it's something we could think of in the future. In this case we had to revert back to this idea of the pin machine, and we found manufacturers in the Far East which actually were ready to experiment with pin machines, were ready to form aluminum panels with pin machines. So in the end we came up with this device that basically prints or presses panels to a numerically controlled system. So instead of being limited to a certain number of molds and a certain number of repetitions, in this case we don't have that issue anymore. We can actually have every single panel different from the neighboring one, still at the same cost. Which is obviously something you all know here that, you know, with 3D printing is possible to achieve as well, and to a very, very high level of definition and detail. That's another building in Baku, in Azerbaijan, where we use a very, very similar system, but it was actually done for fiber concrete. So instead of molding aluminum, in this case we were molding fibers and then casting basically a thin layer of concrete over a flexible mold. When it comes to our use and the kind of extent level of detail that you can put in 3D printing, bearing in mind we primarily use it for architectural models at this stage, this is a very good example, a project where we really exploited. It was a very, very organic and complex project where we had to do a very, very large presentation model over 6 meters long. So it's not dissimilar from the urban scale model you've seen earlier in Ian's presentation earlier. And in this case, the level of complexity of the project and the level of refinement required for the model of that scale really needed a huge amount of 3D printing involved. So we ended up resourcing to different techniques, SLA and SLS, and also vacuum forming some of the glass elements. We had 5 theaters within this complex that we had to print. So we thought, what if we print the inside and the outside of the building? What if we print the seats? So we really can showcase what this building looks like. So in the end, we made this model, which is 4.5 meters. This is when we unveiled it to the press, which is obviously quite a large scale model, where pretty much everything you see was actually 3D printed and then finished by hand. And you could open up the model, you could see the level of details, you could see theaters inside with actually printed seats. So it was really bringing down a level of scale for a 1 to 200 model that wasn't possible without this level of techniques. And obviously that for us broke new grounds. Once we did that, all the next competitions we knew we could do that again. So again, here you see the combination of the different materials inserted. So the glass is actually vacuum formed, and then the rest is a clear resin with a gloss finish, whereas the inside is an SLS, is a traditional SLS finish, and that's the factory where actually this was done in Germany, where with the people. So there was still a huge amount of human labor involved in then assembling the whole model together once the model was finished. This is some of the projects I'm currently involved with, and in Australia and in Malaysia, where we actually use 3D printing from, let's say, the competition presentation phase, the internal design review phase, and the client, obviously the client reviews and the development of the project, all the way down starting from massive models to analyzing facade details. These are the Kuala Lumpur towers, these models are 1.5 meters tall. And in here, I wanted to show the glass, and I wanted to show the building form, and I wanted to show this solid exoskeleton skin. So what we ended up doing, we ended up using a combination of techniques where we actually had a clear acrylic sheet, which was vacuum formed to shape to match the negative of the 3D printing, and painted, and then we left the SLS unfinished because that gives you quite a still kind of good solid look, and we could still print all the inside details, the core. There's even people in tables inside the office floors, but obviously we could showcase, let's say, the inside of the building and the outside at the same time. That's the work in London actually where we were assembling this. So actually that's how the glass got made with 3D printed molds, which then were used for vacuum forming. And a whole very complex system to then obviously monitor that. Whereas that's the second project for which we had to do, because of the peculiarity of the site and the client requirements, we had to do an awful lot of study models and massive models. So the client gave us an initial brief, but then there was a lot of variations and a lot of possibilities. So we were studying one tower. This is roughly 150 meters tall. At the same time, we had to study variations on that tower and that topology to a huge level, a huge scale. So again, obviously we could do that digitally relatively quickly, but the only way to then get proper level of feedback from, let's say, from top management and from the client side was actually printing at least the models of those we picked. We would print them in-house, we would do quick massive models, we would do studies on what happens if you create a variation from 4 elements to 6 elements coming together. What if you add facade details element and grooves to it? How does it meet the ground? So with the same tower shape, how do we actually come to fix to the ground? So we do all these studies and we print them off and we evaluate them and we showcase them. And that's obviously a great way for us to get a very, very quick level of representation. Obviously there is no intention here to actually show a pretty image of something that is not going to be pretty. We show you the crude massing and volume what the final building will look like. In this case, it's actually let's say we're showing 2 towers. One is actually built now. That's pictures from 6 months ago, and that was the final study model we did before going to site. So we actually, it was actually nice and fun to see that we can check the build versus the printed model. A competition entry where we actually ended up putting a lot of facade details to it and in interior details. So we actually didn't put the glass in because there was so much complexity in the facade that you could just make out where the glass would be without needing an actual surface there. We also do, let's say, at later stages of the project, we also do use 3D printing for detail models, where it comes to, let's say, studying the interior of a particular building, layouts of an exhibition center, or even a one-to-one model of a door handle, where we actually wanted to make sure it works. So, most of the times you get reactions from the client, especially when you work with non-conventional geometry and things they haven't seen before, where they tell you, would my hand fit? Is this the right shape? So you print it for them. We had a nice exhibition in our gallery in Goswell Road, where we actually showcased some of the projects we did, and they were all printed. And I think that's the project, and the last project I'm going to show you today, which is project is now on site in Macau that Jim was referring to early on, where it's possibly the most complex project on which we're working on at the moment. It is a hotel tower for one of the Macau casinos, or entertainment complex, as they call them there. It's an exposed exoskeleton structure. So if you imagine this building doesn't have any columns inside, all the structure is what you see on the facade, and then there is some solid concrete cores that actually give you additional stability. The advantage of having an exoskeleton to the outside is obviously that you remove the need of creating a very rigid, intrinsically rigid structure. This level of triangulated connections are rigid by geometry, so all the wind loads are taken on by the facade, whereas normally you have to make very, very thick cores because the columns can just carry vertical weights. They're not able to carry horizontal loads in case of typhoons, earthquakes, and heavy wind loads, which we have in these particular conditions. Obviously, the peculiarity of the design is the hole. So apart from the structural system, is the hole in the center, which is actually 3 holes with these 2 bridge levels, where we actually have some special accommodation for the hotel. So on one, we have a double-story restaurant, and on the other one, we have some special activities. And obviously, this is really kind of the core and the highly complex part of the design, where we have a truly free-form area with a free-form glass and with a very, very, very complex geometry, 3D printed, very complex geometry exoskeleton. When it comes to the inside, obviously, we still pick up some of the features of the outside, and that's one of the areas where actually it could be interesting thinking about using innovative materials, innovative techniques. At the moment, we're thinking of possibly laser cutting, but that's possibly an area where we have a little bit more room for experimentation, because obviously in facades, you have a great level of limits in terms of performance required. So I don't think we're just there with the technology yet. This is what the view you will see from the inside as you enter the atrium. You have lifts on the 2 sides, and then you can look up straight into the voids of the building as you move up. We had to do a very large presentation model when the building was launched in Macau. That was just before the summer. We ended up building the model in China, in Guangzhou, and one of the reasons for that, it was actually cheaper. We didn't have to transport it from London, and we do have an office in Guangzhou because of so many projects we have in China. So what we will do, we'll send them 3D files, they will check them, and they'll send us their mistakes. This file was obviously too big for them to handle, so we had to cut it in parts. They'll check how the model fit together. We had, due to the complexity of the building design itself, we had a lot of surfaces which were not watertight. And in this particular case, the guys doing the 3D printing would not fix them for us. So they would actually send the model back to us, and we had to make sure the model was right to go straight into the machine. We first printed a model in London to do wind tunnel testing. Again, that had to be 3D printed. We couldn't normally, with wind tunnel testing, you actually build physical models. In this case, just the sheer complexity and scale of the structure needed a 3D printed model to actually depict the actual geometry of the surface and to showcase what was let's say, the wind reaction and wind speeds we're getting around this building. It's interesting to see that some of the top speeds are actually around the square corners and not so much in the free-form area. On the same building, we did construction 3D print study models, where we actually were studying with engineers how would they actually screw those nodes in place, and how would they assemble them, and how would the aluminium capping and the cladding will go on top of that. So we would do those drawings ourselves, because the engineers, obviously, they're not geared up to do this kind of studies, so we will take them on ourselves. That's the presentation model. The technique is fairly similar to the ones we've seen before, with the only difference that in this case the acrylic is actually machined, it's not vacuum formed. And then it was a clear 3D print with a silver finish. That was Zaha presented it in Macau a few months ago for the opening ceremony. And I think this where it becomes very interesting, because then I saw these images and that reminded me of the beginning of the presentation, where it's basically we are now going through the process of building the project, and the project is being built by formed sheet metal materials, and that goes back to our original models we were doing in the end, the paper models. In the end, to build the mock-up of this building, that's a 70 meters mock-up, which has been built in China, and it's just for the structural part. They'll now put on the cladding and they'll put on the glazing to it. But what was interesting to me is that they then had to go through a totally new process, and the engineers and the manufacturer had to then again rationalize the surface to find the right way to build the geometry we've given them. And what if they could just print the model we've given them to get to a material which has the right thickness and the right performances without having to go through the process of bending flat sheet material, reassembling it to get to this level of complexity on site.